Solubility can be described in a few different ways. In the last video, we explored the idea of the solubility product constant. Like all equilibrium constant, this number describes to us how far to the right a reaction will go, or in this case, the solubility. If the K value for a certain salt is larger than another, it is more soluble. If a K value is smaller, it is less soluble. Another way of describing solubility from an earlier chapter is by describing how many grams of the solute dissolve in a certain volume of solution. The last way that we're going to talk about today is called molar solubility. Which describes the number of moles of solute that fit in a liter of saturated solution. If a question is asking for the molar solubility, what they really want to know is the number of moles of solid that dissolved in a given volume, not necessarily the moles of a particular ion that is produced. Let's stick with the calcium fluoride example from the previous video. In this reaction, don't forget that we have 2 fluoride ions forming for every 1 calcium fluoride. Okay, now that I've got the reaction ready, I feel a rice table coming on. Originally, when this solid salt is put into water, we're not going to have any of our original reactants. We can label the change in this scenario as S for solubility. Remembering to multiply by 2 for this change section to match the molar ratio in the balanced chemical equation. Now we can see that my equilibrium values of my aqueous species will be in variable format S and 2S. So what we'll do is we'll write out the solubility product constant expression, which will have the calcium ions and the fluoride ions squared for the fluoride ions. And I will go ahead and rewrite that KSP value I found in a textbook, 4.0 times 10 to the negative 11 for this particular salt at 25 degrees Celsius. And then write in my expression. It is really important to remember our basic algebra when we're doing these kinds of questions. At this point, we need to distribute the squared, which will mean this 2 is going to change into a 4 because of 2 squared, and that s on the inside will be s squared. So we'll end up with s times 4s squared, which if we combine our s's, will end up being 4s cubed. We'll set that equal to the equilibrium constant. And then now it's just some simple algebra, dividing by 4. And then once we get that, we end up with 1.0 times 10 to the negative 11 equal to s to the third. Now the easiest way to get rid of this power in your calculator is to put both sides to the power of 1/3. This will cancel out this 3 and leave us with s on that side so that we can get our answer. So if I plop that into a calculator, I end up with 2.2 times 10 to the negative 4, remembering that my units are moles per liter for these types of questions. This value, this S, is what we call the molar solubility. A follow-up question about solubility could be finding that solubility in grams per liter. At this point, all you would need to do is multiply the molar solubility by the molar mass of the solid salt. So all I would need to do is multiply my molar solubility by 78.08 grams per mole to get the solubility into units of grams per liter. This would end up being 0.017 grams per liter if you use stored numbers in the calculator.